Hello students, welcome to CATCH25 Academy. Let us now start with problems of JEE exercises. So in first question, we have a block which is placed on a horizontal surface. So this is the horizontal surface, this is the block. Now this block is being pushed by a force. So let us say we have a force which is a push force F making an angle theta with the vertical. So with the vertical we have angle theta. The coefficient of friction between the block and the surface is mu. We have to find the force required to slide the block with uniform velocity. So we want uniform velocity in this case. That means acceleration is 0. Velocity is constant means acceleration is 0. So we have to find the value of this force F. So let us take the components of this force. So in this case, we have two components. One is this component and one is this component. So in this case, let us think about the angle theta. This will be angle theta here. So this component will be F cos theta and the horizontal component will be F sin theta. Let us say the mass of block is M. So in this case, the friction force will be in backward direction. Let us say small. In vertical direction, we have one force which is mg, other force which is normal reaction. So if I do vertical force balance, I will have one vertical force is F cos theta, another is mg. So upward force in vertical direction is equal to downward force in vertical direction. So who is the upward force in vertical direction? It is F. N is the upward force. Normal reaction is the upward force. Normal reaction is exerted by the floor on the mass. Downward force is exerted by F cos theta, the component of F, and weight of the block, which is mg. So this is the Newton's law equation in vertical direction. Coming to Newton's law equation in horizontal direction, we have rightward force equals leftward force. So who is the force in right direction? It is F sin theta. And we have friction force in left direction whose value is mu into n. So we can say in effect F sin theta equals mu n. So this is the equation in vertical direction. Let us now substitute the value of n in horizontal equation. So if I substitute n value, I will get F sin theta equals mu into n, which is F cos theta plus mg. Because leftward force equals rightward force, we can say block moves with constant velocity or zero acceleration. So F sin theta on simplifying comes out to be mu into F cos theta plus mu into mg, giving us F into sin theta minus mu cos theta equals mu mg. So the final expression for force comes out to be mu mg upon sin theta minus mu cos theta. So the correct option which matches is A option. So in this case, we have the correct answer as option A. Then moving on to our next question, which is second question. So in second question, we have a block which slides with some velocity 10 meters per second along a horizontal rough surface. So this is the horizontal rough surface. This is the block on the horizontal rough surface. The block comes to rest after covering a distance of, so there is some distance after which the block comes to rest. So it is sliding with 10 meters per second initially. Final velocity is 0. And the distance covered is 50 meters. So we have to calculate the value of mu k in this case. So how will we calculate? Let us first use kinematic equation. V square is u square plus 2as. So acceleration comes out to be v square minus u square upon 2s. So v square is 0 minus u square is 100 because 10 square is 100 upon 2 into 50. So acceleration in this case comes out to be -1, which is actually the retardation. Now, this retardation would be due to the friction force, which acts in backward direction. So friction F equals ma. So in this case, mass of the block. In this case, we are not given the mass of the block. So friction is mu n. Friction, maximum value of kinetic friction, we have constant, which is mu k into n. So ma is mu k into n. So m into a, which is -1, or we can say magnitude of acceleration, we can take as 1 itself, is equal to mu k into n, normal reaction. Now this is mg, normal reaction in upward direction is n, which is mg. So n equals mg. Cancels on both sides and we get mu k is 1 by g, which is 1 by 10. So mu k comes out to be 0.1. So in this case, we can say the correct answer is option A, 0.1. Moving on to question number 3. We have a block which is kept on a horizontal table. So suppose this is the horizontal table and on it we keep a block. Mu s, it is given to us as, so let us first make the legs of the table. These are the legs of the table. Like this. So this is our table. And this is the block. Now, in this case, the coefficient of static friction is 0.5. The magnitude of a force acting upward at an angle 60 degree from the horizontal. So this is the force. It makes an angle 60 degree with the horizontal. So we have to find the value of this force so that it just starts moving. So let us take the components of this force. This is F cos 60, and in vertical direction we have F sin 60. In vertical direction we also have mg, and in behind direction we have friction, which is, let us say, Fs maximum, which is mu sm. So along horizontal direction we have F cos 60 is equal to Fs max. Along vertical we have F cos theta plus normal reaction is equal to mg, because normal reaction also acts in upward direction. So in this case, we can say horizontal equation, it will simplify as mu s into n, which is the maximum value of static friction, is F cos 60, which is F by 2. Now in vertical direction we have F sin theta, which is F sin 60. Vertical direction we have F sin 60 force, which is this force F sin 60. So from this, n comes out to be mg minus F sin 60. Sin 60 is √3 by 2. So from this, mu s into mg minus F √3 by 2, this equals F by 2. Now, in this case, what are we able to find? We want to find the value of F. So let us first substitute the value of mu s. So mu s comes out to be 0.5 mg. So m mass is it given to us? Yes, we are given 1 kg into g is 10 minus F √3 by 2 is equal to F by 2. So from this we have 10 by 2 minus F √3 by 4 is equal to F by 2. So if I take this on the other side, we have minus becomes plus. plus 2f by 2 into 2, which is 4. So here we'll have 4 in the denominator. So from this 5 into 4, which is 20, is f into root 3 plus 2. The value of f comes out to be 20 upon 1.73 plus 2. So this is 20 upon 3.73. So 20 upon C 3.73, it comes out to be 5.36 approximately. So the correct answer to this question is option B, 5.36 Newton. Then moving on to the fourth question. Fourth question, we have a heavy chain which lies on a horizontal rooftop. So this is our horizontal table. So we have a heavy chain. Let us say I show the chain in golden color. Now, if the coefficient of friction is 0.25, maximum fraction of length that can overhang. So we have to find the length that can overhang. Suppose this is L dash and the total length is L. So L minus L dash is the length on the table. So total length of the chain. I'm assuming L. Overhang length. Let us say it is L dash. So the fraction. What are we able to find? Maximum fraction of length that can overhang. This is L dash upon L. We need to find this value. L dash is the length overhanging upon total length L. Now, if I assume lambda is m by L, so m equals lambda L. So total mass of chain hanging is equal to lambda L dash. Mass of chain on table. This is lambda into L minus L dash. Now, in this case, we can say this force here m dash into g. Hanging mass, let us say, is m dash. So m dash into g equals this force here, and which is nothing but friction force. So m dash into g is friction force. So m dash into g is mu into n, which is mu into mass of here chain on table, which is L minus L dash into lambda into g. So from this, what I am able to find, m dash I will substitute as lambda L dash is equal to mu into lambda into L minus L dash into g. And here also we have g, which cancels out. Lambda also cancels out. So we get L dash is mu L minus mu L dash. So let us do the simplification. L dash plus mu L dash is equal to mu L. So from this we get L dash is mu L dash upon L is mu upon 1 plus mu. So our answer to this question is L dash upon L is mu upon mu 1 plus mu. Value of mu, it is 0.25. So 0.25 upon 1.25. So it comes out to be how much? So it comes out to be 20%. So 0.25 upon 1.25 is 1 by 5 into 100. 1 by 5 is 0.2. 0.2 into 100 is 20%. So the correct answer to this question is option A, 20%. Now, coming to next question, which is fifth question. In fifth question, we have a horizontal surface. On it, we keep a block. Now, there is a force acting on the block at some angle. So this is O, and with the vertical, it makes an angle theta. Block has a mass m. It is also having a horizontal force P. Another force is Q, which is this force, which is at an angle theta to the vertical. The block will remain in equilibrium if coefficient of friction is. So we have to find the value of mu. So we want equilibrium. That means this block should not move. So rightward force should be leftward force, upward force should be downward force. Who is the upward force? In this case, we have normal reaction, which is acting in upward direction. Also, we have the weight of the block. Weight of the block acts in down direction. So weight of the block, let us say, is in downward direction, which is mg, and normal reaction acts upward, and friction acts in horizontal direction. It is in backward direction. So friction is mu n. Other than that, we have the components of this Q force. So one force component is this, another component is like this. So this component will be, this angle is theta, so this angle is theta. So this is Q cos theta, and this is Q sin theta. So along horizontal direction, we have rightward force, which is Q sin theta plus P. Equals friction, which is mu n. Vertical direction, we have N equals mg plus Q cos theta. Substituting this value of N here, we get Q sin theta plus P is equal to mu into N value will substitute as this, mg plus Q cos theta. So Q sin theta plus P upon Q cos theta plus mg. This is the value of coefficient of friction mu, which we want to find in this question. So mu comes out to be which option? So fifth question, we have the correct answer as option A. So option A is the correct answer. P plus Q sin theta upon mg plus Q cos theta. Next, let us take sixth question. In sixth question, we have a card and we have a block. And we have the wheels. So this is the thing. And we have a horizontal surface. This is our horizontal surface. The acceleration of the system is given as small a. Now, in this case, we have to find the coefficient of friction so that both the blocks move together. So let us see how to solve this question. What is the coefficient of friction? So one force will be mg, other force will be friction in upward direction. So friction is equal to mg. Now, for this diagram of A, we have one reaction force, let us say N1 by this card on the block. So N1 equals MA. Now, in this case, we are expected to find the value of mu. So friction force is nothing but mu n, 1 in this case, which is mu MA, because N1 is MA, because N1 is MA. So mg equals mu MA. So from this, mu comes out to be G upon A, or A comes out to be G upon mu. So our correct answer is option B, G upon mu. Then next question, seventh question, we have two blocks. Both these blocks are kept on the horizontal surface. We have a force which is capital F, which is applied on the block. This is small m, this is capital M. In this case, we are given coefficient of friction between two blocks is mu1, and coefficient of friction between ground and horizontal surface, which is and block M, is mu2. What is the value of capital F? So that both the blocks move without separation. That means static friction acts. So the static friction on block is, first of all, the acceleration of the system will be F upon m plus L. So in this case, we have to find the value of capital F. So let us see how to find the value of capital F. So A is F upon m plus n. Now, let us consider, if we consider them as a system, so m plus m into G, normal reaction in friction in backward direction. So this value of friction F2 is mu 2 into n plus n into G, because friction is mu2 into n. So n is n plus m into G. because this force and this force are equal. So if I write this friction as mu n, which is equal to mass into acceleration. Mass of what? System. So mu2 into m plus m into g, the frictional force, is equal to mass, total mass of system, which is m plus m, into acceleration a. So from this, I can write this. This is nothing but capital F. Force is capital F. We want these two blocks to move together. So in that case, we have to try to find the maximum value of a capital F force. So let us consider the individual free body diagrams. On this diagram, so let us consider individual free body diagrams in this case. Let us first draw the diagram of small m and then capital M. So on small m, we have a force which is, let us say, N1 normal reaction and Ng. These are the two forces. Friction on this acts in forward direction. So let us say the friction is F1. Static friction will act in forward direction on this. And we have friction F1, which is the reaction force of this F1. So this is also F1. And this capital M is moving in forward direction. So friction F2 will also act in backward direction. This is the friction by the ground on block of mass capital M. Then we have normal reaction, which is N2. And we have the normal reaction N1 and weight Mg. So capital M into G. And we have normal reaction N1. Also, we have the applied force capital F. So in this case, we want to find the maximum horizontal force so that both the blocks move together. So acceleration of the system is force, net force on the system, which is capital F in horizontal direction. So other than that, we have a friction force as well, F2 in backward direction. So this will be the acceleration. So acceleration is net force on the system, which is capital F minus small f2 upon capital M plus small m. F2 friction, this will be mu2, which is the coefficient of friction here, into m plus m into g, because friction is mu n. So in this case, F2 is mu n2. N2 is m plus m into g. So acceleration will be F minus mu2 into m plus m into g upon m plus m. Now we can say from this equation, so we are having this equation for acceleration. So in this case, we will have the value of friction F1 on the upper block. It will come out to be M1 into A, where M1 is mass of the upper block, which is small m. Now, F1 is MA. So from this equation, let us write value of friction as mu1 into N1 is equal to M into A. What is the value of N? The value of N1 is nothing but M1G, which is small m into G. So mm cancels on both sides and we get the value of acceleration A as mu1 into G. So let us substitute this value of acceleration as mu1 into G. So mu1 into G comes out to be F minus mu2 into m plus m into G upon m plus n. So from this, I want to value of F. So F comes out to be, in this case, mu1g into m plus m plus mu2 into m plus m into g. So the answer to this question is m plus m into mu1 plus mu2 into g. This is the value of capital F. So the correct answer is applied force maximum value will be m plus m into mu1 plus mu2 into g, which corresponds to option D. Now, next question, question number 8. So in question number 8, we have a similar situation in which we have two blocks. Let us say this is 3 kg, this is 6 kg, and the applied force is capital F. They are kept on a horizontal surface. Now, in this case, coefficient of friction between A and B is 0.4, and we want to find the horizontal force to move without separation. So let us see how to solve this question. Common acceleration is total force upon total mass at capital F upon 3 plus 6, which is F upon 9. So the acceleration is applied force upon 9. Next, let us consider the 3 kg block. We have N1 normal reaction, 3g downward force, which is the weight, which is 30. And we have, in this case, friction, which is in forward direction. So this F1 is M1 into A. So 3 into F by 9, which is F by 3. So F1 friction is F by 3. N1 normal reaction is 30. So friction is mu N. Mu into N1. So mu, which is 0.4 into N1, which is 30, is equal to F by 3. So from this, F comes out to be 1.2 into 30, which is 36 Newton. So the maximum applied force for which the two blocks move together is 36 Newton. Then let us consider next question, which is question number 9. So we have two blocks which are as shown in the figure. So first of all, let me draw the blocks. Now we have a thread which I'm showing in yellow color. This thread is other end is connected to a block of mass, let us say. Value of this mass, let us consider as M2 as per the question. And this is mass M1, this is small m. Now, in this case, we have to find what additional mass should be placed on M1 so that there is no acceleration. So we have to find the value of mass on M1. So let us calculate this mass, small m, whose value we need to find. So one force here is tension, another force here is tension. Coefficient of friction between these and this is mu. So we can say friction will be backward direction, small f, which is mu into m1 plus m into g. So tension force, the rightward force, is equal to friction force, which is the leftward force. So m2 into g, this is the tension force, m2 into g, is equal to friction force, which is mu into m1 plus m into g. So m2 into g is mu m1g plus mu mg. So small m is m2 into g minus mu m1g upon mu g. So GG cancels on both sides. Small n comes out to be M2. So small n comes out to be M2 minus mu n upon mu. So this is the value of small n. So the correct answer to this question 9 is option B, which is M2 by mu minus M1. So correct answer is B option. Now let us solve the next question, which is question number 10. So in 10th question, we have an inclined plane like this. And there is a pulley on the inclined plane. And we have a thread. So this is the diagram. This is mass M1, this is mass M2. In this case, we have coefficient of friction, which is mu. So let us say in this case, what should be the value of M2 so that M1 slides upward. So we have to find the value of M2. This is M2G, this is tension T, this is tension T here. And because the tendency of motion is upward, friction will be backward. And M1G sine theta will also be backward, where theta is angle of inclination. So T comes out to be friction force plus M1G sine theta. So T comes out to be mu into N, which is M1G cos theta. Why? Because in this case, normal reaction N1 is equal to M1G sine theta. Cos theta, sorry. So this is M1G cos theta plus M1G sine theta. Now the value of tension is M2G. So M2G is mu M1G cos theta plus M1G sine theta. So GG cancels on both sides and we get the value of M2. It is mu M1 cos theta plus M1 sine theta. So in 10th question, we have correct answer as option A. M1 bracket sine theta plus mu cos theta. Then moving on to next question, which is question number 11. We have to find the value of M1 so that it slides downwards. So we can do the same analysis as in previous case. In this case, friction will act in upward direction. So let us see the diagram. So this is our diagram. M1 and M2. Here we have tension force, M2G, tension force. In this case, this slides downward. So friction will be up the incline. And we will have M1G sine theta in downward direction. So this is M1G cos theta. This is normal reaction N. So friction is mu into M1G cos theta, mu N. Friction is mu N. Now, Newton's law equation, big force minus small force is mass into acceleration. So big force is M1G sine theta minus small force is T plus F is equal to mass of block M1 into acceleration 0. So M1G sine theta equals T plus F. But T value is M2G plus friction is mu M1G cos theta So this is m1 g sine theta. So this is question number 11. So m1 block in this case, m2 block in this case will be m1 g sine theta minus mu m1 g cos theta. So the correct answer in this case is GG cancels on both sides. M2 is equal to M1 bracket sine theta minus mu cos theta, which is option B, which is the correct answer to this question. Now next question, 12th question. We have an inclined plane which is rough. On it we have a 8 kg block. Angle of inclination is theta. Now downward motion can be prevented by upward force F. So let us show this upward force as capital F. If I apply upward force of 2F, it slides upward. So that we have to find the value of coefficient of friction. So this is 8g sine theta. So F, in this case, friction acts in upward direction because it is stationary. So this is 8g sine theta. So capital F plus mu 8g cos theta. Because normal reaction is 8g cos theta. This is 8g sine theta. So F equals 8g sine theta minus mu times 8g cos theta. Now, in this case, it slides upward. So friction is downward, mg sine theta is downward. So 2F is equal to F, which is friction force. This value will be mu 8g cos theta plus F plus we have 8g sine theta. So upward force 2F is 8g sine theta plus friction force. So from this, if I substitute this value of F here, so 2 into 8g sine theta minus mu 8g cos theta equals mu 8g cos theta plus 8g sine theta. From this, if I take hg common and cancel, I will get 2 sine theta minus 2 mu cos theta equal to mu cos theta plus sine theta. So we have to find the coefficient of friction, mu. So 3 mu cos theta is equal to sine theta. So mu comes out to be tan theta upon 3. So the correct answer to 12th question is option A, 1 by 3 tan theta. So that is how we solve 12th question. Next, let us take 13th question. In 13th question, we have an inclined plane and we have a mass capital M. And there is a string here which has a tension T. Now, in this case, mass is 15 kg for the block. The block is tied to a horizontal string which has a force of 50 Newton. Coefficient of friction we have to find out. So in this case, let us consider the forces. One force is 15g sine theta. Another force is 15g cos theta. And we have normal reaction in. And we also will take the component of this tension. So this is the block like this. And here string is like this, tension force T. So this angle is theta, so this angle will also be theta. So this is T cos theta. And this is T sine theta. T sine theta is in this direction. And T cos theta is in upward direction. So T is 50. So what are the forces acting? 50 cos theta, 50 sine theta, 150 cos theta, normal reaction and 150 G, 150 sine theta. So we have to find the value of coefficient of friction. The tendency of motion in this case is in downward direction. So friction will be in up the inclined direction. So friction is mu into N. And here is sum of these two, 50 sine theta plus 150 cos theta. So from this, if I do the force balance, I will have 150 sine theta is equal to 50 cos theta plus mu into 50 sine theta plus 150 cos theta. Now, in this case, we are given theta as 45 degree. Let us use that fact, theta is 45 degree. So 150 sine 45, which is 1 by root 2, is equal to 50 into cos 45, which is 1 by root 2, plus mu into 50, 1 by root 2, plus 150 by root 2. So root 2 everywhere cancels, and we get mu as 100 upon 200, which is 1 by 2. So the value of mu comes out to be option A, which is 1 by 2. So the correct answer to question number 13 is option A. Next, let us consider 14th question. So in 14th question, we have two blocks, which are A and C. And in between, we have one more block. Now, in this case, friction coefficient between B and C. So this is A, this is B, and this is C. We are applying a force which is capital F. Minimum value of F. So we have to find minimum value of this force F to prevent B from slipping downward. So B does not have to slip downward. For that, we have to find the minimum value. So in this case, friction coefficient between B and C is mu. So here we have mu. So in this case, friction will act in up the inclined direction. So this is friction force small f. And this is mg, the block. Other than that, we will have normal reactions. We are applying a force here, capital F. So there will be a force on block of mass small n, which is, let us say, some force N1. And there will be a force N2 from backside as well, from here. In vertical direction, we have friction F is equal to mg. So this is static friction is equal to mg. So let us see how to solve this question.